Hi everyone. All right, it's time for video number 2. It is time for not ecology. I'm sorry. It's time for earth science. Let's get this review going. All right, the first few words that we see here, we see crust, we see mantle, and core. Those are important words. Those are our layers of the earth. So let's take a look at them in our notes. All right, so the crust. The crust is the layer on the outside of the planet. You look at right there, it is right on the outside, and it's not very big. It's only 35 kilometers deep. It's very thin and very cool compared to the other layers. And it's a little thinner under the ocean. We can see that right here. It's thin under the ocean because there's not as much land on top of it, right? Now, after the crust, we have the mantle. Now, the mantle is very thick. Look how thick it is compared to the crust. This is very deep. Now the mantle has warmer and softer rock, and it's 2,855 kilometers deep. Now, we have a lot of movement happening here, and we'll get back to that later in the review. For now, let's keep going to our third layer, our middle layer, the core. The core is the center of the planet. It is the hottest part, and some scientists even think it's as hot as the sun. Now, the core is surrounded by melted rock, and it is 6,371 kilometers deep. It is way down there. Let's see what else is on our study guide. After that, the core here, we have plates. Now, plates are pieces of crust that are under continents and oceans. So these are the parts of the crust that are right underneath continents and oceans. And the thick pieces that can move. The thick pieces of crust that can move. And they get moved all the time, right? They get moved through something called tectonic theory. Let's take a look at that really quick. I got to go down a little bit here. So remember, when I say theory, theory is an idea that explains how or why something happens. In science, we have to have evidence to support it. Now, the theory we're talking about, the theory of plate tectonics, talks about how plates can move. And there's a really good picture we look at when we're trying to understand this, and this is the picture. Now, heat in the mantle causes the plates to move. This heat is coming from the inner core and the outer core. The core is giving heat to the mantle, and that heat creates convection currents. These currents are melted rock, and as the melted rock gets hot and heated up, it rises, and as it rises, it gets cooled, and as it gets cooled by the crust, it slowly starts to move back down, and this movement back down moves the crust. And remember, the parts of the crust that can move, that's called the plates. So the heat from the mantle, as it moves up, these heated rocks will move the plates. And as the plates and the crust cool these rocks off, they're going to sink back into the mantle. And when they're back into the mantle, they're going to pick up heat near the core again, and then they're going to come right back up. So that is our, that's our theory of, what do we call it here? We called it our plate tectonic theory, or theory of plate tectonics, and it uses convection currents. It's important to know. So we're going to go down a little bit more, and we see two more important key words, magma and lava. So these are easily confused, but you guys can know these. A lot of you learned these pretty quick. So when it comes to lava and magma, there's a key difference. They're both kinds of melted rock, but magma is melted rock inside the earth. Under the earth, it is magma. The minute this melted rock leaves the inside of the earth, it comes to the outside. When it explodes onto the surface, that's lava. And it is also melted rock, but we call it lava. Inside the earth, we call it magma. Let's go down a little further. All right, we've got two kinds of weathering here, mechanical weathering and chemical weathering. Now, these are important things to know. Mechanical weathering is when rocks are broken naturally. They're broken into smaller little pieces. We're not changing anything about them. We're just breaking them. And we've got a couple of different examples when it comes to mechanical weathering. We've got two right here. This is ice wedging. Water freezes in the cracks of rocks, and as it freezes, water expands, slowly pushing the rocks apart. And here we have another one. We have a tree starting to grow in there, and I believe I have a few better pictures than that we're going to take a quick look at. I just got to go down in my notes here really quick. Alright, so this is plant and animals can cause mechanical weathering. Another one that's really good is abrasion. Abrasion can cause weathering. It can slowly rub rock. Slowly through friction, it rubs rock. So that's mechanical weathering. There's also chemical weathering. And in chemical weathering, we're changing the atoms. We're permanently changing what material this rock is. We're changing the core elements of the rock. So this can happen through a couple of different ways. Now, the most common ones are going to be rust and acid rain. Now, acid rain is going to slowly dissolve whatever it touches over time. Rust is going to affect anything with iron in it, any sort of specific metal, and it's slowly going to degrade the metal, which means it makes it weaker, easier to break. I wouldn't ever try and break metal, but rusted metal I think I could break because it's weaker chemically. Alright, so let's look at what other words we have here. Ooh, erosion and deposition, important words. So weathering is the breaking apart of material, and then we have erosion, moving it. Remember this picture, right? Erosion is moving the broken material. So weathering breaks it apart, and then erosion moves that broken material somewhere else. Sometimes, while things are moving, things can also get weathered. But the process of moving these broken bits of rock is called erosion. And wherever they end up, wherever the rocks, wherever erosion pushes them, wherever they stop, that is a deposition site. This is where deposition happens. And at deposition, we get new and new layers on top of each other. Of course, this takes a lot of time. This is not something that happens overnight. So deposition happens over a long period of time. Is it not something that just happens, right? Alright, let's see what else is on our study guide. Ooh, next we have the rocks. Okay, we got 3 different types of rocks. We're going to come back to this picture in a moment. We got sedimentary rock. So sedimentary rock, as shells and bones and bits of rock start to collect, and they start to be squeezed together, really tight squeezed together, they become sedimentary rock. You can usually see sedimentary rock because it's got all these different parts in it. Now, metamorphic rock is slightly different. Metamorphic rock does take a little bit of squeezing, but we have to add some temperature. We have to make it warmer, right? Metamorphic rock is heat and squeezing. And that results in rocks like these. You can see the different parts of them here, but you can also see kind of the wavy lines in between here. That's very indicative. That's a good example of a metamorphic rock. Now, our final kind of rock is called an igneous rock. An igneous rock is created when we let something melt completely. The rock is melted completely. There's no more pressure. It is just heat. And once this rock cools down and is able to get hard again, it becomes an igneous rock. So this obsidian is an example of an igneous rock. So we can find this deep in the mantle, deep near the core, or we can find it on the surface, especially when lava, melted rock, comes up onto the earth. It will melt and become igneous rock. So again, here's a picture of the convection currents, right? Here the convection currents carrying that mantle. Remember, cold air or cold rocks will sink, warm air or warm rock are going to rise. That movement of warm rock in the mantle is what's going to cause the plates on the crust to move. Alright, I see ecology is creeping up here. Ecology calls for another video. So that's the end of the Earth Science Review video. I hope this helps, and I'll see you in the next video, and I'll see you guys on Monday. Good luck.